Hey guys, hello everyone and welcome to the channel. So this particular video is going to be about 10 tricky numerical answer type questions and MCQs from your quantum chemistry. Now quantum chemistry is one of the most important and highly scoring topic from your physical chemistry, especially in the GATE exam. So the video or this particular class is going to be in such a way that it will help you to analyze and understand that what type of questions are asked from your GATE exam, so that in exam if the questions are asked you can simply answer them. Now, before going into the video, let me tell you about my classes which are running right now on Unacademy Plus. So I take live classes on Unacademy Plus, and the course for physical chemistry is running right now over there. So if you are interested to join those classes, you can take Unacademy Plus subscription using my referral code, that is N_Huda. For other details, you can mail me in the email ID provided in the description of this video. Alright. Now having said that, let's continue with our video. Alright guys, let's talk about this particular question which was asked in GATE 2020 exam. This question was asked for 1 marks and it's a pretty simple question. It says, among the following linear combination of atomic orbital, the correct representation for lowest unoccupied pi molecular orbital of butadiene. Now by far now, I guess if you are following my videos, you can simply do this question very easily. Okay, to do this question it's just very simple for you. So butadiene means you have CH 2 double bond CH, single bond CH, double bond CH2. This is the molecule. You will have 4 molecular orbitals, and out of those 4 molecular orbitals, the LUMO, that is lowest unoccupied pi molecular orbital, and HOMO you have to understand. Okay, so I'm just going to make those 4 orbitals. So those 4 like molecular orbitals can be simply drawn with the help of these lobes. Okay, so these are going to be the lobes of each carbon which I can draw. So this is, let's say, the lowest one, then comes the higher than that. All right, and this is then again the higher one of that, and this is the highest one. Okay, I have to change the sign or the color of these lobes in order to explain it. So the lowest one does not have any node in that, so 0 node, so that's why this is called as your psi1. It's very important to know how to construct these molecular orbitals. Okay, this I have already explained in linear combination videos, so you can watch those videos as well. This particular one will have 1 node, so that node will be present at the center here, so that means the sign will change from this particular position. All right, the third one will have 2 nodes here and here, so the sign will change from here like this, and this is how the lobes will be colored. And the highest one will have 3 nodes between all of these, so sorry, the sign will change like this, and then again the sign will change. So here you have 1 2 3 nodes. Okay, so this is psi1, this is psi2, this is psi3, and this is psi4. You know the number of nodes is n minus 1. Whatever energy level you have, you just have to take 1 less than that to find out number of nodes. Now you have to fill the electrons. So in order to fill the electrons, how you are going to do, just you have 4 pi electrons, 1 2 and 3 4. Each pi bond correspond to 2 electrons, so just fill them. So this is how it is going to be filled. So this becomes your HOMO and this becomes your LUMO. So they are asking about LUMO here. Okay, lowest unoccupied pi molecular orbital. Now if you look upon the sign here, so the sign should change 2 times. Okay, like you have to look upon the orbital where the sign changes 2 times. So just look upon this. So if you see it, if I call this shaded region as the plus sign, so the sign of this LUMO is nothing but plus minus minus plus. See, this is plus minus minus plus. The shaded side is the plus side. So now you have to look upon the wave function where you have this plus minus minus plus type of like this type of your sign. So that you can see that is in option number B. So plus minus minus plus, that's the only one where the sign has changed. How many times? The sign has changed 1 time and 2 times, so 2 nodes should be there. So that is only present in option number B. That's why option number B is the correct option. So these types of question are very simple. You just have to approach it based upon the number of nodes in them. All right, so simple question, simple explanation. Let's go for the next one then. Alright guys, let's look upon this particular question which was asked in GATE 2020 exam, and the question says that the hydrogen like radial wave function which is given to you for the 3s orbital, the wave function is given to you as such, and it says that where rho is equals to 2zr upon a naught, where z is your atomic number, r is the distance from the nuclei, and a naught is your Bohr radii. Now it is asked about the position of the radial nodes. Now since this is a radial wave function, radial nodes will be the where your radial wave function becomes 0, right? That's where your radial nodes will be. So you have to just take this whole equation is equals to 0. That's all. You have to take this whole equation is equals to 0. Now this whole equation comprised of 3 parts. The first part is this much, the second part is this bracket part, and the third part is this exponential part. So any of these parts, if it becomes equal to 0, the whole wave function will become 0, because everything is multiplied with each other, right? So if any one of them becomes 0, the whole radial wave function becomes 0. So let's start from this particular part. So if this particular part is equals to 0, will it make any sense to us? So no, it does not make any sense to us, because there is no r here, okay? There is no value of r. So that means you will just get like 1 upon 9 root 3 and z upon a naught whole to the power 3 by 2 is equals to 0. So all the things are constant over here. So these are all constant. It cannot be 0 basically. Its value will be some constant value, right? So that means you have to look for these two parts, okay? You are just left out with these two parts. Now let's talk about this particular part here. Now this is e to the power minus rho upon 6, and if it has to be equal to 0, let's say if it is equals to 0, that means this particular part, this power part or this exponent part has to be infinite. Why? Because you know that e to the power minus infinite is equals to 0. So that means rho upon 6 has to be equal to infinite, or we can say that rho is equals to infinite. Now if rho is equals to infinite, that means if I put the value of rho from here, which is given to me in the question, that means 2 zr upon a naught, this also becomes equals to infinite. Now if it becomes equals to infinite, my radii or the distance from the nuclei is basically infinite. So that means I am in a boundary condition. See, for hydrogen atom problem, there are two boundary conditions. One is when the r is equals to 0, the other one is when r is equals to infinite. So these are two boundary conditions. So for example, when you take particle in a box, you consider a particle in a box. So the wave function, if you draw for that, goes something like this. So the wave function is 0 at the two boundaries, okay? So the boundary condition will always have a 0 radial wave function. So that is of no use. The other nodes, the nodes are actually here, right? Here and here. So that means the points where the radial wave function will be 0 other than the boundary condition will give you radial nodes. So you have to just look upon this part now. Alright, so for this I'll use the other slide. Alright, so I am having this particular as 6 minus 2 rho and plus rho square upon 9. That's what I have, right? So plus rho square upon 9, and I have to take this equals to 0. Now this is a quadratic equation basically. Quadratic equations can be solved. I just have to take LCM over here. So this is going to become 54 minus 18 rho and plus rho square is equals to 0. I have taken LCM, multiplied 9 with 0, so the denominator just got vanished, right? So this is what I have now. This equation, or I can write down it like this: rho square minus 18 rho plus 54 is equals to 0. Now this equation can be simply used, can be simply solved based upon the SD formula. What is SD formula? The SD formula says that x square, if I have ax square plus bx plus c is equals to 0, if I have an equation like this, then x can be calculated as minus b plus minus under root b square minus 4ac upon 2a. This is the formula which we call Sridharacharya formula also, alright. So this you might have done in class 9th or 10th somehow. So just from here, if you see, the value of a is 1, b is minus 18, c is 54. Put all the values to calculate your rho. So rho will be nothing but it will be equal to minus 18 plus minus under root minus 18 is square minus 4, a is 1 and c is 54. Solve this and divided by 2a. So 2 into 1. So just calculate this. I have already done. So I'll just show you that what actually it becomes. So I have just solved this particular part, and after solving you are going to get rho is equals to 18 plus minus, on solving this you are going to get 6 root 3 and divided by 2. Alright, that's what you are going to get. Now that means rho has two different values. One rho value will be what? The one of the rho value is equals to 18 plus 6 root 3 upon 2, and the other value is 18 minus 6 root 3 upon 2. Alright, so these are the two values which you have got. But in the question they are not asking about rho. Let me tell you once again. So if you look upon the question, they are asking about the radial waveform, the radial nodes. They are not asking about rho. So you have to substitute the value of rho now. Okay, you have to substitute the value of rho as 2z r upon a naught, and you have to tell in the terms of a naught. So just put the values of row now and calculate the value of r. Okay, r is what you have to find out. So if you substitute that, I'm just going to do here on the next slide. So I'm going to have 2zr upon a naught, and this is going to be equal to 18 plus 6 root 3 upon 2, right? This is what I have got. Now basically what I can do is I just have to calculate r. So r will be equal to 18 plus 6 root 3 upon this 2 will come this side, so it will become 4, and this will become a naught and divided by z. This is what you will get, and the other value of r will be 18 minus 6 root 3 a naught upon 4z. You can take 2 common to divide from numerator and denominator. So the final answer which you are going to get will be 9 plus minus, I have just combined both of them, 3 root 3 divided by 2z a naught. So the answer in the terms of a naught will be 9 plus 3 root 3 upon 2z and 9 minus 3 root 3 upon 2z. This is going to be the final answer. Alright, so this was pretty simple. You just need how to calculate it. So let's come back to the question and see which is the correct answer for us. Alright, so in the question you have got 9 plus 3 root 3 upon 2z, 9 minus 3 root 3 upon 2z. So the correct option is option number C, and these are the values of your r at which the radial wave function will be 0, and that's why these are the nodes of this particular wave function. All right, simple question and simple calculation. Just it looks little difficult in the verbal form, or when you look upon the question it looks difficult, but it's very simple to solve. Let's go for the next one then. Alright guys, let's try to solve this particular question, which was again asked in GATE 2020 exam, and it was again asked for 2 marks. It says that the percentage error that is rounded off to the 2 decimal places in the ground state energy of the particle in one dimension box of length a described in the trial wave function. The wave function is given to you where x is in the boundary condition from 0 to a. Alright, the true ground state value or the actual ground state value is h square upon 8ma square. That is also given to you, and if you integrate from psi star psi d tau from 0 to 8 will give you a to the power 5 upon 30. So these all data are given to you. You have to use that to solve it. Let's try to do how. Let's try to see how it will be done. First thing is you have to know the formula for percentage error. So percentage error can be calculated as this, that is E trial, okay, minus E actual or E true. You can write down actual or true, both makes the same sense, divided by E actual or E true. Okay, so this is the formula to calculate it. Now we already know about the actual value which is given to us. We don't know the trial value. Trial value can be calculated from the wave function, trial wave function given to us. For this we have to use the Hamiltonian to solve it further, and we know that the Hamiltonian is equals to minus h cross square upon 2m, and it's dou 2 square upon dou x square. This is the value of the Hamiltonian which we have. Now what we have to do is we have to find out E trial. Okay, E trial will be equal to from 0 to a integration of your phi star h phi divided by 0 to a phi star phi d tau. Alright, now the value of this denominator is quite given to us in the question. We just need to solve the numerator. Once we know the numerator, we can put it here to find out E trial. Once we know the E trial, we can put it there to find out the percentage error. So what we have to calculate is the numerator part of this. So let's try to do on the next slide. Alright, so all you have is you have to solve 0 to a and phi star h phi d tau, right? That's what you have to solve. Now we know that phi is given to us as x and a minus x, and this is only going to be your phi star also. So nothing to worry, just put both the values here. Also fine, so if I multiply it here, I can also write it down as ax minus x square, right? That's what I can write down. So if I put it here, so this will be 0 to a, and this will be x and a minus x, and h value will be minus h cross square upon 2m d2 by dx square, okay, and x and a minus x and dx. This is what I will have if I substitute every value here. Now what I have to do is I have to just solve this, okay. So on solving this, what I am going to get is 0 to a. Now this is going to be x, and a minus x will remain as it is, and this particular part, that is minus h cross square upon 2m, can be taken outside because that's a constant term, and in this bracket I will have d2 upon dx square of what? Of ax minus x square, because if you multiply, ax minus x square is what you will get, right? So yeah, fine, this is what I have done. So I have to just differentiate over here. So I can just do it in rough. If I do it in rough, I'll show you like this. So d by dx of your ax minus x square will be equal to how much? This will be equal to a minus 2x. And if I do d again, if I take differentiation of this, that means if I take d2 by dx square, so this will be like yeah, d2 by dx square of ax minus x square. So this is going to be equal to d by dx of ax minus x square. Now this value I have already find out, it is this much. So this is d by dx of a minus 2x. A is a constant, differentiation of a constant is 0, x is a number, sorry, x is a variable, so differentiation of x will be 1. I'll just get minus 2, so minus 2 will be the value. So 2 times differentiation of ax minus x square gives me minus 2. I can simply substitute it over here. So 2 times differentiation of this is going to give me minus 2, so I can put minus 2 here. So what I'm going to get is this, minus h cross square upon 2m was already here, integration from 0 to a x and a minus x, and this value is going to become minus 2. Alright, simple as it is, and dx. Now this minus 2 can be simply cancelled out, right? We can simply cancel out this minus 2 with this 2, and this minus will become plus. Minus minus will cancel out and they will become plus. So I am going to get h cross what will be left out? H cross square upon m. All right, minus sign will be removed, 2 is cancelled out, integration of it has become ax and minus x square. I'll just multiply here, and dx. This is what I have now. And from 0 to a, I have to separately integrate it, so I'll do it on the next line. So it will be h cross square upon m, in the bracket it will be like integration from 0 to a of ax dx minus integration of 0 to a of x square dx. Little complicated but pretty simple. Next line, what it will be? H cross square upon h cross square upon m, in the bracket this a will not get integrated, x will get integrated, and it will be x square upon 2, upper limit 0 to a, okay, upper limit lower limit, minus this x square will be x cube upon 3. You know, x to the power n has an integration of x to the power n has an integration of x to the power n plus 1 divided by n plus 1. So 2 will become 3 divided by 3. X to the power 1 will become 2, like x square divided by 2. Simple as it is. From 0 to a. Just multiply and solve. So in the next line, what I am going to get is h cross upon m will remain as it is. Here if I put upper limit, it becomes a square upon 2, and when I multiply with a, it will become a cube upon 2. My 0 will make it 0 only, so no need to put that. Minus if I put here, so it will become a cube upon 3. So solve this particular part, and you are going to get h cross square upon m. Take LCM and solve, and it will become a cube upon 6. This is what is the value of the numerator part of your E trial. Let's substitute it. So my E trial is going to become this particular value came out h cross square upon m, and this was h cross square upon m and a cube upon 6, and the value of this is already given to me. This is a to the power 5 upon 30. So let's put this value out, and when you solve this, you are going to get h cross square upon m. Alright, so this particular part will become a cube upon 6 multiplied by 30 upon a to the power 5. Solve this, and this is going to make it as h cross square upon m 5 times. So this will be 5 upon a square. Okay, so this is the value of my E trial. Now E trial is what I know, and E trial is what I have calculated. E actual is what I know. I can substitute to find out my percentage error. Now one more thing is there, that here you have h cross. You have to convert this h cross in terms of h, so that you can cancel out, or so that you can calculate it further, right? So you know that h cross is equals to h upon 2 pi. So that's the calculation part which you have to do. So this will become h square upon 4 pi square m and 5 upon a square. This is the value of your E trial which you are going to get, and E actual you already know. Put both these values here, E trial, E actual upon E actual, to get the percentage error. So let me show you how it will be done. Right, so this was the equation. E trial we have calculated as h square upon 4 pi square m, and this was like a square upon 5 upon a square. So this was what, and E actual is equals to this is already given to you in the question, that h square upon 8 ma square divided by h square upon 8 ma square. Now you can take this h square upon 8 ma square common, and you can cancel all these things. All right, so 8 ma square, you can cancel out that. You will only left out with 5 upon 4 pi square minus 1 upon 8 divided by 1 upon 8. You have to use your calculator to solve this, and at the end you are going to get the value over here. All right, so the value which will come out at the end is going to be 0.0136. Since you have to mention it in percentage, so you have to multiply it with 100% to get the value in percentage. So the value will be 1.36%. This is going to be the percentage error in the answer. So it was a numerical answer type question, so the correct answer is going to be 1.36%. all right, so see, so simple it was, but it is little lengthy. Calculative part is little lengthy, but when you have calculator, things will become little easier for you. All right, let's go for the next one then. All right guys, let's look upon this particular question which was asked in GATE 2019 exam, and this question was asked for 2 marks. It was very tricky question, many people did this wrong. I have already discussed about this question in very detail in a video. I'll give you a link of that, you can watch that video also if you want to understand it in more detail, but I'll just explain you how it will be done. Okay, so to answer this question, you cannot go to this question directly. Okay, it was asked that suppose the wave function of the one dimensional system is given to you, and they were asking you that in the experiment measuring the momentum, you have to tell of the system one of the expected outcome is. They're asking about the expected outcome. Many people directly just applied the momentum operator on this wave function, and they just tried to find out the expected outcome, but that was not the correct way to solve this. The correct way to solve this was to convert this E, like this sine theta, sine function, and this this particular exponential part in the cos particular form. Okay, cos and sine form. So basically how it will be done, you should know about this formula, that sine x, okay, can be written as e to the power ix minus e to the power minus ix upon 2i. all right, similarly cos x can be written as e to the power ix plus e to the power minus ix and divided by 2i, whereas tan x can be written as e to the power ix minus e to the power minus ix divided by e to the power ix plus e to the power minus ix. all right, so these are the form in which you can convert sine theta and cos theta in the form of exponentials. Now this whole calculation, like how it came, this you should know, you should remember them, but how it actually came, this came from the binomial expansion of the sine theta and e to the power ix. okay, so you can calculate, you can find out the binomial expansion, and you can justify that LHS is equals to RHS. But fine, that is not needed for this particular class. You just need to know that what it is. Now what I'm going to do is I'm just going to substitute its value over here. So my wave function psi is going to become e to the power ikx, because I don't have just sine x, I have sine kx. So it will be e to the power ikx minus e to the power minus ikx and divided by 2i and multiplied by e to the power 3ikx, right? That's what I have here. So I can just multiply and open the bracket. So my psi will be 1 upon 2i, and in the bracket I will have, when I multiply it with it, so it will become e to the power 4ikx, because base is same, so power will be added. So 1ikx plus 3ikx will be 4, and minus e to the power 2ikx. all right, this is what you are going to get as your wave function. Now this is the wave function which you have to use, or which you have to apply the operator on, and you have to see the expected outcome. So let's try to see that how it will be done. All right, so now you have to just find out the outcomes. So for that you have to operate the linear momentum operator on the wave function. So the linear momentum operator is minus I h cross dou by dou x on psi. So let's put the value of psi. So I'll have minus I h cross dou by dou x, or d by dx. and psi is e to the power 4ikx minus e to the power 2ikx divided by 2I, and yeah, that's what I have. Alright, so now you can just write it down like this, minus ik, and this differentiation can be d by dx of, you just have to differentiate them separately. So e to the power 4ikx minus minus d by dx of e to the power 2ikx, and whole thing is divided by 2I, that 2I is here itself. Now you should know that d by dx of e to the power ax gives you a e to the power ax. That means whatever the coefficient you have, that will get multiplied. So I'm just going to do that. So this will be minus ik, and here if you do it, so this is going to become 4ik only, and it will be e to the power 4ikx minus this will be 2ik and e to the power 2ikx and divided by 2I. Now you can just divide with 2I separately. So basically you are going to get something like this. Okay, I can just multiply with this particular value. Alright, so I just missed out it should be equal to minus I h cross. Okay, so it should be h cross. Alright, so if you multiply inside, this becomes, this particular value will become 4 h cross k, and I will become I square, and I square is minus 1, so that I square will cancel out this minus sign. So you can just write down if you want one step, e to the power 4ikx minus, and this minus will become plus, and it will be 2I square h cross k e to the power 2ikx divided by 2I. Now you can simply separate it out. So basically you are going to get this I square is minus 1, so it will remove this minus sign. So 4h cross k e to the power 4ikx minus, because this I square is minus 1, 2 h cross k e to the power 2ikx, and whole thing is divided by 2I. So this is what we are going to get. The two possible values which we have is going to be either 4h cross k or 2h cross, or this 2h cross k. So because these are the coefficients which you are getting, like these are the eigenvalues which you are getting. So if you come back to the question, you don't have 4h cross k, you just have 2h cross k. So this becomes your correct answer for the question. So many people did this question wrong in the exam. When it came, many people did it as 3h cross k or 3ih cross k. The complete solution, if you want it in more detail, if you have missed any point, you have not understood any of the point, if you want to understand it in more detail, I have explained in 14 minutes in very detail. That solution is there in the I button. Okay, you can click over there and you can watch that video. This particular question is explained in very detail over there. All right, let's go for the next one then. Alright guys, let's try to look upon this question, which was again asked in GATE 2019 exam and for 2 marks. Okay, so this was from GATE 2019 exam. The question says that the particle in one dimension box of length 2a with potential energy which is given to you is perturbed by a potential of Cx electron volt, where C is constant, and the first order energy correction is being asked, for the first excited state. So let's try to look upon the perturbed part is Cx over here, and it's like multiple of C is what you have to answer. Now for particle in one dimension box, you should know the basic things like what's the wave function will be. So wave function is equals to 2 upon L and sine n pi x, okay, n pi x upon L, n pi x upon L. This is the wave function which I have. Alright, so now since they are talking about the first order energy correction for the first excited state, so that means your n value should be equal to 1. Just put n is equals to 1. So your wave function psi will become under root 2 upon L and sine pi x upon L. Okay, this is what you are going to get. Now remember that L is equals to 2a here, because your particle is from your like between 2 of length 2a. Okay, it's given to you, the length is given to you as 2a. Now that is not going to like affect much to the solution. What you have to do now is you have to use the first order energy correction formula. If you don't know about how to calculate first order energy correction and all, just watch my video on perturbation theory. I'll link that video. Okay, I have explained the perturbation theory and everything over there. So first order energy correction is going to be from minus okay, so from where to where it is. So your particle is from your like potential is 0 and infinite. The particle is of length 2a, so we are going to take it from minus infinite to plus infinite. and then you have a psi x, it's a wave function of x, so psi x, and then you have the perturbed part is cx and multiplied by psi star x and dx. All right, so this is what I have written. Now you can substitute the values here. So if you put psi x and psi star x, both are going to be same only. So your value is going to be like 2 upon L can be taken outside of the integral from minus infinite to plus infinite, and it will become sine square pi x upon L into cx. Alright, so this is what you are going to get. Now remember that the value, there is just a shortcut trick which I will tell you, that if you are integrating from minus infinite to plus infinite, and if you have x, sine square pi x upon L, and if you are doing this, this should be 0 if your power of x is odd. Okay, so if the function is odd, in that case you get 0. So if function is odd, now since x is 1, so that's why the power of x is 1, so the function becomes odd, so that's why this whole thing is equals to 0. So this whole bunch of thing will become 0, and the answer, the first order energy correction comes out to be 0. The correct answer is 0. Simple calculation. You just need to know that what actually this first order energy correction means, okay, and what this particular thing, that what happens if the function is odd. Alright, let's go for the next one then. Alright guys, let's talk about this particular question. This was again asked in GATE 2019 exam. This was a 2-marker question, very simple question, but asked in a little complicated way. It says that if alpha is a wave function and sx, sy are spin angular momentum operators. Now remember, this is a Dirac notation. This is Fermi-Dirac notation in which the equation is given to you, and this is CatBra notation. If you don't know about this notation, if you have not studied about it, I'll link in the I button. I have explained this whole concept over there. All right, so just watch that video and understand what this CatBra system actually is. Now to answer this question, you need to know the basics about the momentum operators. Okay, you know about the angular momentum operator. This is a spin angular momentum operator, but the angular momentum operator, which is denoted as Lx, Ly and Lz, I think you already know about them. So you should know some basic formula regarding them, that if you do commutation of Lx and Ly, this is going to give you IH cross Lz. Okay, that's what you get. Similarly, if you do Ly and Lz, in that case you get IH cross Lx, and if you do Lz and Lx, in that case you get IH cross Ly. If you reverse the order, the sign will change, the sign will be negative here. Now in the same way here, instead of Lx and Ly, you have Sx and Xy. Okay, now that is a spin angular momentum operator, nothing different. So same thing will be there. So if I have, let's say, Sx and Sy, so that is going to be equal to IH cross Sz. As simple as that. Okay, this is what we are going to apply. So see here, if you look upon the Dirac notation which is given to you, which says that alpha and then you have Sx, Sy minus Sy, Sx, and then again your bra vector of that. So this, the thing which is in the center, this is nothing but AB minus BA, right? AB minus BA, which is a form of your commutation, which is a form of your commutator, right? AB commutation of A and B. So this can be written as alpha, and this particular thing can be written as commutation of Sx and Sy, right? Now this whole thing Sx and Sy is actually equal to IH cross Sz. So this will be alpha and IH cross Sz, right? So I have just used that. Now IH cross is a constant number, so that can be taken outside. So IH cross will be taken outside. I'll get alpha Sz alpha. Though that means that I have to apply this Sz operator on alpha. Now alpha is what? Alpha is a spin up eigenfunction. A spin up eigenfunction means its spin value is plus half. Okay, so its spin value is actually equal to plus half. All right, now that's what you have to substitute here. So if you substitute the value of a spin half, so S, remember this, that if you are operating the spin angular momentum, that means you want to find out the spin, and if you are doing it on the spin half like spin up eigenfunction, in that case you should get plus half H cross. Okay, so plus half H cross is what you should get. So basically that's what I am going to get. So I can just substitute in the place of this whole thing where sz is being operated on alpha. I can substitute plus half h cross. So it will make it I h cross, and this will be alpha, and the value of this is going to be like, this is going to be something like this. Okay, I have not written it completely. Yeah, this is what it will be. So because it's a eigen function, right? So basically when you operate a spin angular momentum operator on a spin up eigenfunction, you get plus half h cross and the eigenfunction back. And similarly, if you were having a spin down eigenfunction, then in that case you would have got minus half h cross. All right, so just substitute its value here. So basically I'll just erase this, and you are going to get it as all right, so just put the value here. So you have got plus half h cross. So plus half h cross, plus means that plus sign I can just ignore also. Okay, and then I am going to have, so basically what I am having is half h cross, and since this alpha was already there, so this new alpha or this bra vector of alpha is written over here. Now this is a normalized wave function, so obviously its value will be equal to 1, and you are just going to get half I h cross square. So they were asking the value of a, right? So if you compare it with this, so your a will become half, that means 0.5. So this is going to be the final answer for this question. To understand this, you should be aware about CatBra notation and how calculations are done in that case. So I have just done it because I have already explained it in my previous video. So if you don't know about it, please watch those videos. All right, let's go for the next video then. Alright guys, let's talk about this particular question which was asked in GATE 2018 exam. It says consider the operators. The operator is given to you as a plus 1 upon under root x plus ipx, and a minus that is equals to 1 upon under root 2x minus ipx. Now here x and px are basically position and linear momentum operators. You have to tell about the value of a plus and a minus. So it's pretty simple to solve. I'll just show you how it will be done. So basically you have a plus and a minus, that is where you have to operate it on operator psi. So this will become a plus a minus minus a minus a plus, okay, and you have to operate it on wave function psi. Just put the values here. So the values of a plus and a minus you have to substitute. So 1 upon under root 2 and x plus ipx, and multiplied by 1 upon under root 2 x minus ipx, minus you have 1 upon under root 2 x plus ipx, and multiplied by 1 upon under root 2 x minus ipx. All right, this is what you have. So and you have psi to operate on, okay, on both these parts you have psi to operate on. So simply what you have to do, open the brackets now. So it will become 1 upon 2, multiply here, it will become x square, and minus it will become x ipx. Now multiply this, so it will become plus ipxx, and this will become minus I square px square. If you open this, so this is how this bracket will get open, minus the other part of the bracket if you solve, so this will again become 1 upon 2. Okay, so I shall basically write it like this. This will become x square, and this will be minus x and ipx, and this will become like this particular thing is going to become plus ipxx and minus I square px square. All right, this is what I am going to get over here. All right, I just messed out with the sign here. It has to be, okay, this sign has to be this, this signs should be different. Okay, this has to be minus and this has to be plus. All right, so with that, if I do, this will become plus and this particular one should become minus. All right, so this has to become minus. All right, now you can just open the bracket. So 1 upon 2 can be taken outside of the whole, and this will become as x square minus x ipx and plus ipxx minus I square px square. If you open this bracket, it will become minus x square minus x ipx, and this minus will become plus ipxx, and this minus will become plus and it will be I square px square. Now you can cancel out the terms which can be easily cancelled out. X square and x square will be cancelled out. I square px square, I square px square will be cancelled out. Remember to put psi, don't miss out your psi. So psi should be there. Now what you are getting is 2 times of this function, right? Minus 2 times of this and 2 times of this. So I can just use the left out portion of the screen. So I am just going to write down it as 2 times. Okay, 1 upon 2 is outside. In the bracket I have 2 times of I px into x, and minus I have 2 times of x I px. Okay, x I px and psi. That's what I have got. So what I can do is I can take 2 and I outside. So I can take 2I and divided by I. So in the bracket I will have pxx minus xpx psi. Now this again became a commutation equation. You can see these are all operators. So this became a commutation operator of your xpx. Okay, so this 2 and 2 will get cancelled out. You will just get from here, you are just going to get I, and this whole thing can be written as commutation of your x and px operator and then psi. Now you know the value of x px, the commutation of x and px gives you I h cross, right? Minus I h cross. So you can put the value over here. So this is going to be I and minus I h cross and psi, right? So if you solve this, so I will become I square is minus 1, this minus 1 will cancel out this minus sign, and you are only going to get h square psi. So the answer is going to be h square, which is your option number C. So the option number C is going to be the correct answer. This is how it has to be calculated. Little tricky to do, but pretty simple to approach. Okay, so let's go for the next one then. Alright guys, let's try to answer this particular question which was asked in GATE 2018 exam. Again, this question was from your very basic quantum chemistry. It says that the molecule xy, let psi x and psi y denote the normalized atomic orbital of atom x and y. The normalized molecular orbital of xy is given by psi plus is equals to 0.56 psi x plus psi y. What they are asking is the value of overlap integral. So simply you can write down your psi plus as equal to 0.56 psi x plus 0.56 psi y. What I have done, I have just multiplied with it and opened the bracket. Now simply if you compare it with a wave function as psi is equals to c1 phi 1 plus c2 phi 2, this is the standard form of a molecular orbital wave function which we have, which is found by the linear combination of two atomic orbitals or two atomic wave function, which is psi 1 and psi 2. c1 and c2 are the coefficients over here. So the equation to find out your overlap integral is calculated as c1 square plus c2 square plus 2 c1 c2 s is equals to 1, where this s is called as your overlap integral. You can use the same equation to solve it over here. Now here your c1 is also 0.56, c2 is also 0.56. You just need to solve it. All right, so just use the calculator to do it. So according to that, you will have 0.56 square plus 0.56 square plus 2 times of 0.56 multiplied by 0.56 into s, and that should be equal to 1. So by that you can simply calculate it. So your value of s should be equal to 1 minus 2 times of 0.56 square and divided by 2 times of 0.56 square. Okay, that's how you can just simply calculate it. So you just need to put the values, like you just need to use your calculator to solve it, and its value will be roughly around 0.59. So that is going to be the value of overlap integral. All right, so this is going to be the final answer for this. All right, so this is how it has to be done. Let's go for the next one then. Alright guys, let's take the last question for this particular video. The question is asked in GATE 2017 exam. It says that psi is equals to c phi 1 plus 1 upon root 3 psi 2, phi 2 represent a normalized molecular orbital constructed from two different atomic orbital phi 1 and phi 2 that form an orthonormal set. The value of c is, okay, they are asking the value of c, that is this. So let's try to do this. So if psi is equals to, let's say, c1 phi 1 plus c2 phi 2, I have just taken an example where psi is a wave function constructed from two atomic orbitals, two atomic orbital wave function phi 1 and phi 2. Then in that case, if this is a normalized wave function, okay, if it is a normalized wave function, so in that case I have a particular condition for that. The condition is that c1 square plus c2 square should be equal to 1. This is the condition which it should follow in order to become a normalized or orthonormal wave function. So similar condition we will try to apply on our given wave function. Our given wave function is phi is equals to like psi is equals to c phi 1 plus, sorry, minus 1 upon root 3, and we have phi 2. So if you substitute the value, this particular equation is going to become c square plus 1 upon root 3 whole square, and that should be equal to 1. So c square plus 1 upon 3 is equals to 1, or basically you can solve it further, and this is going to become c square is equals to 1 minus 1 upon 3. C square will be basically 2 upon 3, or c can be equal to under root 2 upon 3. So mod of c will be positive. This is going to give you plus minus value, but since mod of c is asked, you just have to take positive value. So under root 2 upon 3 is the positive value, like positive value of that. So the correct answer after calculation is going to be 0.81. Okay, so this is going to be the final answer after using your calculator to solve this. So this is how this answer will come, and that's your correct answer. Alright, so in this particular video, we have taken the previous few year of question of your GATE exam. There are many questions which are already there on the channel, which I have solved for the previous years of GATE exam, of CSI NAT exam from the quantum chemistry chapter. So I'll highly recommend you to watch each and every question, how it is being approached, how it is being solved. That will help you in the upcoming exam to solve it easily, right? To approach the question easily. See, the question is not that difficult. It's just about how you approach it. So that makes the whole difference about the question solving analysis. Now that's all from my side, guys. Thank you so much for watching this particular video. I will see you in the next one. Just if you have liked the video, give it a like. If you have not subscribed to the channel, please do subscribe to it, and I'll see you in the next one. Till then, have a great day. Bye bye.